Thank you for joining us today. We have another amazing show and a terrific guest. Today, we are talking about what it means to potentially have direct ownership of orbital infrastructure. Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Barry Matsumori. He is the Chief Commercial Officer at Eclipse Space. Welcome to the show, Barry.
Thanks for having me. Great to be here.
Absolutely. Maybe we can start by having you give a little bit of background on yourself and Eclipse Space.
Yeah. I've come originally out of the mobile telecom space. I'm an early Qualcomm employee. Spent a number of years there, and then got recruited from SpaceX by SpaceX, and they hire somewhat not normally because they looked for a telecom guy, and here I was. Joined them in 2011. Stayed there for about 4 years, and since then I've been part of two startups that have had ex SpaceX people involved: Impulse Space and now Eclipse Space. So it's one thing's for sure: working with ex SpaceX people is very good.
That's amazing. Okay, well, so why do you see that? Now you've piqued my interest.
There's a lot of many people know SpaceX, and there's a lot of aspects that people know about them. But one thing's for sure, and that's working in that environment. It's a bit grueling. On the other hand, you're very dedicated to the work, focused, and that kind of, if you will, training is clear in the people that come out of SpaceX. And so, yeah, I've seen it before and seeing it again.
Wow, fascinating. Well, so tell us a little bit about what Eclipse Space is doing.
Eclipse Space is formed out of some principles from formerly from SpaceX Starlink, and we're based in Redmond, Washington. And the whole point is to look at what are the global needs for satellite constellations, particularly around communications, and can we help those people that want their own constellation, do not want to go to a common carrier, if I can use that term, to get communications capability, control it on their own, and look for a provider that can do that. And that's what Eclipse Space is.
Wow, amazing. So let's talk a little bit more about that. How do you see the whole idea of, I guess, sovereignty or ownership of
Hmm.
that infrastructure evolving over time, especially as you look at not just nations and commercial companies, but also mobile operators?
I think sovereignty, that's a term that is guided by one key term, and that is control. Being able to control the asset that you own. If you use a common carrier as a communications provider, it is up to the common carrier to provide that control, and what you get is what they offer. In many cases, particularly countries, but even those private entities, potentially mobile operators, all want to be able to control the asset that they have. And especially when it comes to coverage and capacity, to be able to control that for the area that you control, the region that you control, is important.
Right, right. What do you think are some of the major criteria that make that decision point as to whether to use like a Starlink or an Amazon Leo as opposed to launching your own constellation?
A critical factor is cost of the constellation. Other factors like performance of the satellite are important, but if the cost isn't providing that competitiveness to own that constellation, then that's going to be a problem. One of the things that the Starlink background that we have is Starlink is the cheapest communication satellite that's ever been built. It is remarkably well costed, and the team that we have understands how that costing works. They were there when they were building version 1, 1.5, 2.0. So those lessons learned not only were learned by these folks, actually they started some of it.
Right. So you're kind of alluding to the fact that it sounds like that satellite hardware that you're flying is a really important aspect of creating a constellation.
It is, but I don't want to forget that it's a system. And so you have to have ground stations. One has to have user terminals. And what we've done is we're not building those, but we certainly have partnerships, deep partnerships that allow us to provide a total system for our customers.
Yeah, yeah, interesting. So it seems like mobile network operators are beginning to take a look at this as a
Mhm.
means of continuing to expand their market and, stay very relevant in the industry. How do you see this?
It's a great point that you raise because anybody that knows the mobile telecom industry, it is very, very competitive. And that's one aspect. And the second part is the growth of 5G networks is difficult because as the generations of mobile technology have evolved, with 5G, every generation has shrunk the coverage area, and 5G has done that even further. So, in order to put a base station down, one has to justify the cost per user to put that base station down. That cost per user is now high enough that the limitations of how far a mobile operator can go into suburban, rural, even less dense areas becomes challenging. And so to find an alternative infrastructure that can provide the coverage, yet provide a cost per user basis that makes sense is difficult unless somebody has a cost effective constellation.
Right, right. So, I guess, how do they, from a mobile operator perspective, look at, I guess, expanding those regions, and how does owning their own constellation support that goal?
I think everyone's aware that there are constellations up there that mobile operators are either partnering with or thinking about augmenting their network, and that's great, except that they're paying a pretty high cost per user basis to do that. So it kind of defeats the whole purpose of growing your network when your cost per user basis is going up.
Yeah.
But if one can do it so that they actually have a competitive product, even as they deploy further, that makes a whole lot of sense.
Yeah, no doubt. We had a question come in about, kind of the economics of satellite, but they're saying that they're really interested to hear more about how Starlink's cost efficiency is reshaping space tech. So I guess, what's your perspective on that?
So, yeah, Starlink costs, I mentioned that Starlink satellite costs are quite good, but as one knows for a space and for SpaceX, what their cost is and what they charge are not necessarily closely aligned because they're like any enterprise. They'll look at what the market can bear, they'll look at what makes sense to penetrate the market, and that's what their pricing is. And Starlink is no different. So I think their cost base is quite good. Their price base is one that allows them to be profitable. And I think that's the difference that is being pointed out. If you're a sovereign, if you want control, if you can get something that's as cost competitive as Starlink or better, and yet control it, that's an ideal solution.
Yeah. How does this all work from a launch perspective? Because obviously, a lot of the launch right now is coming from
Oh, yeah,
SpaceX, which
yeah,
is Starlink.
yeah,
So
yeah.
how does that work, and how will that be sort of a gating factor for getting up these owned constellations?
It's a great question. It's a timely question. Lots of people are concerned about space access right now. If one looks at the capabilities at this particular time, they look a little bit limiting. But if one goes out into the late 27, 28 timeframe, all these other space access providers, whether it's Relativity Space, Blue Origin, Stoke Space, Firefly, there's a number of these companies that are going to be commercially operational, and that capacity is going to show up kind of all at the same time, especially in 28 and certainly in 29. So, yes, a snapshot of right now might be a little challenging, but I think that's going to improve dramatically. And oh, by the way, SpaceX is still going to be there.
Of course. And so do we get to the point where there's a glut or an over availability of
Uh,
launch, do you think?
if those all those companies, not if they will, all those companies will come online. I don't know if there's a glut because there's another thing that's happening, and demand for space is also increasing as one gets more competitive solutions, not only for communications but Earth observation applications, in space processing applications, uh, humans in space with commercial space stations. All of these things are going to lead to an expanded need for space access. So I don't know if there's going to be a glut. I think that's all going to be filled.
Yeah, yeah, yeah. Okay. So, what developments do you think have, as far as space technology, have come and sort of opened up opportunities that really weren't previously there before?
It's good. I think I have to go back to the same point on space access. I was there when Falcon 9 was really not recognized as a vehicle that was anything close to what it is today. Certainly, reuse was not in play when I joined. And Falcon 9 has really shaped the industry because it did a couple of things. Certainly, it was cost effective, but it's not just about cost. More importantly, it's about schedule regularity. Can you predict when you're going to space? Can you build satellites, other assets, so that they can be timed to be ready to go to space on a launch? But prior to SpaceX, the regularity of launch was pretty sparse. PSLV out of India was one of the ones that kind of was regular at that time. And so people liked it because at least they could get a schedule. But that changed everything. And once you can schedule what you're going to do in space, the economics, the how you can predict revenue for your investors, for your users. I'm sorry, for your investors and others is very good, as well as service to your users.
Yeah, indeed, indeed. Okay, so one of the big topics I think in our industry right now is data centers in space. So give us your perspective on data centers in space, and is that going to drive the need for more, I guess, owned orbital infrastructure?
It's There's been a lot of analysis done. You can find various reports on it, and it really comes down to a couple of things, and that's when you have essentially unlimited power that's available in space, and you have unlimited ability to dissipate thermal energy in space, it makes for a compelling opportunity compared to what's on Earth, because on Earth, you have limitations in energy, and certainly environmentally, doing that much cooling is going to be challenging. So, assuming that one can manage thermal energy through a satellite, because I think that's the number one problem. There are other issues, but thermal management of a satellite, getting power in, generating heat, getting that heat managed out and radiate into the darkness of space, that is going to be solved. And yeah, data centers in space is going to, my own idea, it's going to be economically viable and very competitive, if not more competitive than terrestrial solutions.
Okay, you guys heard it here first. So, talk a little bit about the operational and strategic advantages of owning your own constellation, but also some of the complexities that come into place. And you kind of mentioned this earlier, needing ground infrastructure as well as the in space infrastructure. So, talk a little bit about this, both from a here are the advantages, but here are some of the challenges that come up, and I guess how to deal with those.
Yes. So I'll go to a little bit of a perspective that's different, than come back to your question. Why a sovereign entity? Why a country may want to control an asset? And there are a number of applications. Certainly, you've seen hurricanes in the region. When disaster recovery is required and base stations are wiped out, the only way to really do it quickly is from space. and that's one application that sovereigns see. The other one is, of course, military, and that's if you want to be able to control assets or communicate with assets that are terrestrially based, whether on land or marine. The only way to do that really is from space. So those drive a lot of what our sovereigns need. What's the trade-off? The trade-off is they need to become adept in space. And so the first thing when one hands over a constellation is who controls that constellation? If a sovereign wants an entity like Eclipse Space to control it from the beginning, we can do that, and then hand it over when they're ready to do that. There's things like ground stations, but ground stations are all over the world, and one can contract from various companies, including the ones that we've partnered with. We happen to partner with Leaf Space to do that, but there are other ground station providers that can be used. And then user terminals, there are a myriad of user terminal makers around the world, and those can be contracted to provide those assets. That entire system operation is the complexity that someone will have to learn when they really own a constellation.
Or hire the right people, right?
Yes.
Okay. So, well, I guess that brings up another good point, which is I think from a sovereignty perspective, there may be interest in actually, I don't know, being part of that manufacturing process of the satellites themselves.
Mhm.
How does that work? And do you see that as an important factor?
Certainly, the fundamental is if you're offering a satellite, you kind of have to have it manufactured one way or the other. The conventional solution is for a company to provide the manufacturing facility, whether it's the building, the equipment inside, the tooling, all that in order to build some set of the satellite. The fact is, nobody builds 100% of the satellite by themselves. There's connectors, there's cables, there's computational hardware. All of that has to be outsourced. So there's no such thing as, oh, I built the whole thing ourselves. That doesn't exist. We've taken a different approach at Eclipse Space, and that is that what we learned is the satellite, unlike a rocket, the satellite actually is largely outsourced. So in fact, if you look through and see many of the components can be outsourced, and the difference is, do you design the component, the subsystem, the system itself, or do you use a partner to go do that? In our case, what we've done is we've essentially become a design agent, much like Apple does with the iPhone, or my old company Qualcomm did with silicon chips, and that's their design house. And so in our case, we're a design house. We have partners that fabricate all of the components, subsystems, and systems in our satellite, and we have experience actually doing that already. One of the things that people assume out of Starlink is that is a vertically integrated satellite, and actually it's not. It's quite outsourced, and the team that we have actually did that work for Starlink, so we know how to do it.
Wow, amazing. Okay, so looking out into the future, where do you see this all going and just in terms of owned infrastructure that's on orbit? Where do you think we'll be in, I don't know, 5, 10 years?
So the platform that we've developed that starts with communications is a great place to start. There's a market demand. We're going to satisfy that market, but it's a platform that actually can expand into many different directions. You mentioned data centers, and certainly that platform, flat sat form factor, can accommodate data center designs. It actually can accommodate certain Earth observation designs. There's kind of no limit to what can be hosted, and that's where we're going. Again, we're just starting with communications because it's an immediate demand.
Yeah, absolutely. Okay, so we got another question here. Let's see. So, with the idea of data centers in space, so continuing on that topic, will
Mhm.
cloud engineers need astronaut training, or how do you envision maintenance being handled?
Yes. I think I mentioned challenges for data centers, and the one I did not mention, which I think the person that asked the question rightly asked is, okay, it's in space. You cannot send a repairman up to it and have it repaired. So architecturally, things like redundancy and designing for that are going to be key, so that certain failures will not. I mean, it's space; failures do occur. So certain failures don't cause a overall failure of the satellite system, and that's just a design point. But it's a very fair question that one has to see the reliability that is very high in order to maintain such an asset on orbit.
Absolutely, absolutely. Well, Barry, I want to thank you so much for making time to be here today. If someone wanted to learn more about Eclipse Space, what should they do?
They can simply go to our website. It is eclipse.space, and go from there and ask questions. Yeah, be happy to do that.
Excellent. Well, thank you so much for making time to be here today. And I want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leader Show.